Okay, today is the beginning of our review for the Exponentials test. This has been Unit 11, I believe. It's 11, isn't it? Yeah. Unit 11. Okay. And our test is coming a couple days from now. Today isn't the first day of review. Tomorrow's the next day of the review. And then Wednesday, in this case, will be our test. And actually, it's a 2-day test, Wednesday and Thursday. One part's with calcs, one part's no calcs. All right. So I want to show you a big picture, kind of like where we are in the folders, because I know at home it might be confusing. There's so many files in there. The ones I circled in black, the exponents practice quiz, no calculator, that's what we're doing today in class. And your assignment for tonight is going to be the blue ones, where the calculator is allowed. Of course, you feel free to grab your calculator at any point on those. And we'll be doing a lot of graph both sides and see where they cross. That's a great way to get answers that way. Okay. So the red ones there, the top ones, that's the assignment for tomorrow. All right, so please open up Unit 11, Exponents Practice Quiz, no calculator. The top one that I circled in black there. And I'll pause while we get that out. All right, so here's the little practice quiz, which we are going to take, but I want to do a few things to practice with you first. Let's just talk big picture. What are things you have to know? You got to be able to handle it when there's negatives all over the place. Negatives in the exponent are totally different than negatives out in front. And negatives that have a parenthesis around them get treated differently than negatives that don't. So there's a lot of negative stuff to know. You got this kind where you always have to check for what? Extraneous answers, because and you get an answer and it comes out to like -7, then it might not actually work when you stick it back in. You got this kind where you have to get the clump alone. Good. You have this kind where you have to know that when you have powers over other powers, that you do what to them? Subtract them. Very good. And you also have to be able to handle things like these graphs that have been moved and flipped and all that kind of stuff. So we'll practice that stuff right now for a few minutes before we actually take that little quiz. Okay, you ready? First up, let's say you had 1/3 to the -1/2. Now, one thing they could ask you to do is simplify the answer so it doesn't have a negative exponent anymore. Do you get that negative exponents are not allowed in your answers? That's just like part of the rules. You cannot give an answer that has a negative exponent. Because if it has a negative exponent, you should have flipped it and made it happy. Like put it to the other side. All right, so you got to think of this as 3 things. That's saying flip it. That's saying not square it, but take the square root and then put it to the whatever power. In that case, the first power. Okay, so this means flip. This means what root you're supposed to do. And this means what actual power you're supposed to do. All right, so what's the one part I can't have in my answer? Flip. So I actually have to do the flip. So then it flips, and it becomes what? 3 to the what's left? 1/2 power. With parentheses or without parentheses, do you think it'd make any difference in this case? It would not make any difference. If there had been a negative in the base, like if there was a negative here, then you'd need to know whether it was in parentheses or not. But when there's no negative like that, then it doesn't matter if it's parentheses or not. All right. Now, why didn't I actually do the square root part of that? Because I don't know what the square root of 3 is. If I'd have wanted to, do you get I could write this as the square root of 3? It's the same thing. Either one of those is right. Do you get that 1/2 power means square root? In case you hadn't learned that. And if you wanted to get even more fancy, you could put a little 2 there. Either one of those is good an answer, though. Because why is this okay when that wasn't? Because one has a negative power and the other doesn't. Not allowed to have negative powers. All right, so here's one like that for you. X to the -2/3 power. Just fix it so it's legal. Right now, you're breaking the law. And you get thrown in math jail, where they don't let you sleep. And all they do is play math problems to you over and over again, like a train leaves London, traveling 400 miles per hour down the railroad track. Another train leaves London going the opposite direction at 300 miles per hour. Anyways, so You're not allowed to have a negative in the exponent. That means you're supposed to do what to it? Flip it. And so what's your answer? 1 over x to the what? Good. It's done. Do you have to do more than that? Nope, because I don't know how to do the cube root of x. Now, what if this had been a 27 right here in the problem? You could simplify it further? Go ahead and do that, please. Instead of x, let's say it had been 27. Then you can finish the deal. Mr. AK, tell me what to do.
So you do 27
To the
2/3.
Okay, so which part of that do you do first, the 2 or the 3?
3.
All right, third root, not third power. Third root of 27 is,
3.
and then what's this mean? Which means what?
3 times 3, which is 9.
Excellent. The answer is 9 then?
No.
Okay, what about the top then?
It would be 1 over.
Yeah, third root of 1 is still 1. 1 squared is still 1, so it's 1 over 9. Raise your hand if you had that answer. Do you get how a smart kid might have thought? Well, 1/9 is the same as 9 to the negative 1, so I'm going to leave it that way. They're kind of right, but they're kind of wrong because you're not allowed to have negative exponents. Even though 9 to the negative 1 means the same thing, it's not allowed because it has a negative in its exponent. Okay, how about this kind where you have to get the clump alone? 2/3 to the negative 2 plus 4 is equal to, let me think now, x plus 7. No, that's going to be too confusing. I'm just going to ask you to do that. We won't even try to do the clump alone yet. Just that. Hint, to actually add them, you'll need to make them have a common denominator. Something we practice on the top 20. Hopefully you haven't forgotten. To begin with, did you get this thing flipped and then squared? That makes it 9/4. You're on the right track? Okay. Then you want to get a common denominator. So what would be a good denominator? 4. So I times this one by 4 and 4. And that makes me have 16 plus 9 is 25/4. Could you make that into 6 and 1/4? It's the same thing, yeah. But it's extra work. Why not just say 25/4? I know a lot of kids got it into their head that this is wrong to leave as an answer. And I get it. The definition is improper fraction. Makes it sound totally illegal. But we like those answers at the high school. Numbers that like this are better actually than the decimals, like 6 and 1/4, because if it's in the middle of an equation, you'll never see that. 6 and 1/4 A, you'll never see that. Whereas you will see 25/4 A in an equation. Funny looking A, but there we go. Okay, so next kind. Let's say we have square root of 2x minus 3 equals square root of 5x. Remember, just because you're suspicious that you think it might not work, if all you did was cross it off and say extraneous, you'd be wrong. You have to find an answer. Sometimes the answer works. And if the answer doesn't work, then you cross off that answer and say ext, extraneous. I'll pause while you try that one. So here we go. We should square both sides, and you get 2x minus 3 equals 5x. Then you add 3 to both sides, and actually you could, but it'd be smarter to subtract 2x from both sides, because you want to get the smaller variable out of there. Then you get negative 3 equals 3x, then you actually want to divide by 3 right there. So it would save you a step to do it in the order I just showed you. And your final answer is whatever that reduces to, which is what? -1. And if I actually want to check and see if it works, x equals -1. Oh my gosh, I'm glad I checked. Because, look at that, I have a negative underneath the square root. Even if the other side also has a -5 under the square root, which it does, that doesn't mean it's right, because you've probably heard this, 2 wrongs don't make a right. They're both wrong. That side doesn't work, this side doesn't work, and 2 things that don't work can't equal each other, it's just wrong. So you'd say, cross it off, extraneous ext. Sir, I'll let you recover. Yes. Okay, but then it would have to equal the other side, so both sides have to work. If both sides work and come out the same, then you know the answer actually worked. And I've showed you a zillion of them where they don't work, but I'm warning you, sometimes they do. Okay, so now I think you're about ready. Oh wait, one more kind that baffles people. I have 2 dots, and I have to compare them to these other 2 dots and figure out whether it was a stretch or a flip or a what. Okay, so first of all, do you get if this one's rising that has to be a y equals like 2 to the x? It has to be like an exponential one. As opposed to, like, if they were both falling, it'd be y equals 1/2 to the x. Do you get the difference between these? This is like growth. This is like decay. Are you good with that so far? Okay. Now, if we just take a growth one, and let's say that we use this one that I circled and say that it's 2 to the x is the parent one, then what do you need to know from me to know if the thing just got moved up, or whether it got moved and stretched, or, how are you going to be able to tell? The original points, okay? So let's say that this one is at 0, 1, and this one's at 2, and think about it, you know what the answer is. Because you know what the parent function is. 2, what? 2, 4. How do these guys know that? Because they stuck a 2 in right there for x. Because if I put in x is 2, it's like saying x is 2, and therefore y must be 4. So 0, 1 and 2, 4 are my original points. I would agree you need those. Then, what else do you need? Compare it to the other 2 points. Okay, so let's say that the other 2 points, I'm not sure exactly where they are, but let's say they are at 0, 6 and 2, let me think. 15. First, I ask you, did it just move up like 5 or something? Something consistent? No, it did not. Did it just get multiplied by something? No. So then you know it must have gotten multiplied by something, and maybe you added something either in here, left, right, or in here, up, down. I'd like you to figure out what the new equation is. It starts with that blue equation, y equals 2 to the x, and then you have to adjust it knowing that these are the changes. I'll give you a hint. Guess and check. Try something, try something, try something. Find a combo that actually works. You know it works when you can stick this point into your equation and it works. And you can stick that point into your equation and it works. So try to make me an equation like that. I'll pause for a second while you give that a shot. Okay, so a lot of people are stumped. I would just say try something, like try times it by 2 and then try to add something more to make it work. So like, okay, to get from a 1 to a 6, that means it has to go up 5. Timesing 1 by 2 only doubles it, so that's not gonna work. Like, let me show you what I mean. If I put in this point, it should work, 0, 6. I should put in a 0 and a 6. Do you get how 6 does not equal 2 times 2 to the 0? Okay, but what would I need to add to make it work? Okay, this is a possible answer now. because now 2 to the 0 is 1, 1 times 2 is 2, 2 plus 4 is 6. Cool, that one works for that point. Now, does it work for the other point? When I actually stick in, there we go, 2 comma 15, I put in a 2 here and a 15 here. Does that actually work? Is 15 equal to 2 times 2 squared plus 4? No, that didn't work. Okay, so that didn't work. So, who thinks they have it? Come on. Anybody?
Thought I had him in that.
Thought so and it didn't work? What do you think?
3 parentheses 2 x parentheses plus 3.
3 here, and then a plus 3 here. I want you to check him and see if his is right. So what do? Take this, you stick it in 0 and 6. Does that actually work? Okay, but I found a different one that would work for just one of them. It has to work for both. So what's the other one? If x is what, y has to be what? X is 2, y has to be 15. Now see if that works.
It does.
It does. So he got it.
I'm confused about the red stuff though. See, I did get
The red stuff is given. See, the red stuff comes from this original equation, y equals 2 to the x. It tells you that has to be in your answer. We knew it had to be y equals 2 to the x. It's just what to multiply it by and stuff. And he figured out that you times it by 3 and then add 3.
But that would have worked for 0 and 1, right?
But,
Or 4.
okay, let's just see if it really would work for 0 and 1. So if I put in a 0 back to the original equation, remember, just to clarify, this equation right here, 2 to the x, that's supposed to work for 0 and 1.
Oh, yeah.
And that's supposed to work for 2 and 4. Okay? This equation that he just wrote is supposed to work for these 2 points. All right. I think you'll get another practice of that on the practice quiz that we're about to take. So everybody, right now, take that practice quiz. We're going to take about 15 minutes for it, and then we'll take the last 5 minutes to grade it. Okay? I'll give a pause while you try that. Okay, so here's this practice quiz, and here's what you should have had. We're grading that at this point. Students have already done it and exchanged. So this first one, do you get when the negative does not have a parenthesis on it? It's like it just drifts off to the side, waits over here for a while, and you do the problem, and then the negative comes back in on the answer? As opposed to this one where the negative gets actually used on the 1/3. Negative 1/3 times negative 1/3. All right, so anyway, the negative is going to wait till later, and then I have 4 to the negative third. 4 to the third is 64. The negative makes it 1 over 64, and that negative comes back in, and the answer is negative 1/64. If they have something wrong that's like a negative's missing, take off a half a point. On this next one, negative 1/3 times negative 1/3 is positive 1/9. Why can't I just leave it that way? Because there's a negative and that says flip it. And so you flip it and you get 9 as your final answer. On to the next one. Get the clump alone. This is the clump. So you add 13 to both sides and you get x plus 2 to the 4/3 equals 68 plus 13, which is 81. Then you go to the power of 1/3 to the power of 1/3 and, sorry, 4/3. Sorry about that. And the third root, oh, what's wrong with this? 4/3, 3/4, thank you. Looks like it, here's no third. 3/4, this was 4/3. There we go. And we're going to put it to the power of 3/4. That makes a lot more sense because 81 can be put to the 3/4 power. Fourth root of 81 is 3. 3 to the third is 27. Now I have absolute value of x plus 2 equals 27. Then I make two equations out of it. X plus 2 is 27, and x plus 2 is negative 27. Then I get subtract 2, x equals 25, subtract 2, x equals negative 29. So positive, oh, something's wrong here. 25 and, no, that's right, and negative 29. 25 and negative 29. All right, the next one, I want to save some time. I got to go a little bit faster to be able to get out of here on time. And so tell me, this comes down to x equals negative what? 6, and then it doesn't actually work because when you put it in, it's extraneous. So it should be crossed off like that. The next one, it starts out as to the 1/4, so I'm going to put it to the power of 4, and I have 2x minus 3 equals 3 to the power of 4, which is 81, thank you. Then I add 3 to both sides. So final answer, x equals, is it 40 something? 42, thank you. On to the next one. This is b to the 10 minus negative x is equal to b to the 5th. See how I did that? 10 minus the negative x. That means 10 plus x is equal to 5. X equals negative 5. And I will finish this with you guys tomorrow. I'm going to finish it actually right now on the video. So if you guys could file out quietly, that'd be good. So if anybody wants to check it at home tonight, they could. Remember, your assignment for tonight is to do the part where calculators are allowed. Get that done tonight. Got to review heavy so that you're ready for the test. All right, so here's the rest of this thing for those of you that want to watch at home. For number 3, I am doing... All right, so for number 3, this one's just like they had said, x to the negative 4th to the 1/7. So why can't I leave it as x to the negative 4/7? Because that has a negative exponent. You're not allowed to have a negative exponent. So then I have to flip this 1 over x, and now I did the negative part of the problem, and I just leave it to the 4/7. That is a perfectly good answer. Otherwise, if you wanted to do the top to the 4/7 power, it would be equal 1. And then the bottom can still be x to the 4/7 power. I don't know if you think that's any better, but that's an okay alternate answer. Okay, this next one, I like to factor things. 81 factors into 3 times 3 times 3 times 3. And then y to the negative 4th. Those y's aren't happy up there, so I'm going to make them y to the 4th on the bottom. And then there's a 3 on the bottom. And then these y's aren't happy where they are, so they go to the top, y squared up here. That means after I cancel off this 3 and I cancel off this 3, and a y squared is like y, and y to the 4th is like y. All right, I'm going to do that. Now I can cancel off some of those. Cancel, 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 cancel. That's why I like factoring so much, because it leads you to cancel stuff. 3 times 3 times 3 all over y squared, which is 27 over y squared. There's my answer. Okay, I'm going to do this one next. I'm going to do the top part first. 6 times the 5 makes 30. And then x to the negative 4th and x to the 8th makes x to the positive 4th. All over 3 to the 3rd is 27. X to the negative 2 to the 3rd is x to the negative 6th. Why can't I leave it like that? These guys aren't happy where they are. They need to move up here, and I need to reduce that. So I'm going to break this down into 3 times 10 over 3 times 9, and then the x to the 6's go up with the x to the 4th, and that makes x to the 10th. These cancel. 10 x to the 10th over 9. Next one is this gets put to the negative 2/3 power, and then this will get put to the negative 2/3 power. The 27 to the negative 2/3 power. First, I'm taking the 3rd root of 27, which would be 3. And then I'm going to square it, which makes it 9. And the fact that it's got to flip it says 1/9. Then I'm going to take x to the 12th and put it to the negative 2/3 power, but that's like this. If I actually multiply that out, that makes x to the negative 8. Because 2/3 times 12 is 8, and you make it negative because there's a negative in it. So x to the negative 8th. But I don't want to leave an x to the negative 8th on top where it's unhappy. I'm going to make it x to the positive 8th and put it on the bottom. All right, and then on the bottom part of this worksheet, Problem 4, evaluate. So here I'm going to be square rooting first, then cubing, then flipping. Square root of negative, oh wait, and the negative out here, there's a negative, you can't see it at home. The negative has to wait till last, and then I'm going to have 16, and then I'm going to take the square root of that. Square root of 16 is 4. 4 to the third is 64, and the negative makes it 1 over 64. Then I did the 3 steps on the 16, and then the negative comes back in, and the answer is negative 1/64. I'm going to pause for a second. All right, I'm back, and now I'm going to do one step at a time here. The 4th root of 16 is 3, then 3 to the third is 27. That's one of those easy ones I was telling you. There's some easy ones at the end. All right, this next one's pretty easy too. Even though these, sometimes people think these are really complicated, this is just the black one getting moved up 2. How do you make the black one move up 2? Y equals 2 to the x is the general formula for the black one. And then to move it up 2, just put a plus 2 on it. There's my equation for that one. And how do I know it's right? If I'm really right, that point right there, for instance, should go in. And that's the point 1 comma 4. 1 comma 4. Does 1 comma 4 really work? If I stick in the x is 1, the y will be 4, and it actually works. Okay, now moving to the very last question. And this one's tougher. The black one is the one that you start with. That's the parent one. And I hope you can see that this one, the other one's so different that it had to have gotten flipped. In fact, it got flipped like that. Actually, I gotta move that over a little bit, but it got flipped like that. That's an up-down flip. That's taking this y equals 0.5 to the x, and if I'm going to do an up-down flip, that's like throwing a negative in front of it. That is a vertical reflection, officially. Now, where does it have to go to get moved up to where it is here? Well, it has to get moved up 1, 2, 3, 4, 5 spots, and I'm looking at this spot right here and seeing that it has to move up 5 spots. So then I say plus 5. All right, and that's all I've got for you for today. The homework, again, that I had signed tonight is to do the same kind of practice quiz, except the practice quiz that allows calculators. That's your practice for tonight's homework. Have a great day.